Confirm.
Yes, sir.
Yeah. Okay. So today we are going to do an assignment which will be along the same lines that you had done before. However, we will try to implement something. We'll try to implement another protocol, right? We'll try to implement a new protocol whose description I'm going to tell you shortly while I go through the problem statement. So this particular protocol, basically this implementation, as per the specifications of this protocol, you need to implement concurrency. Now this concurrency, you have already implemented concurrency with the help of fork, right? And that you did as part of your second assignment, if you recall. So fork is quite convenient to use, it is easy to use. However, it is not very computationally, it is not very efficient, right? And so there is another mechanism which is called multi-threading. Okay. So today's assignment will be using multi-threading. Okay. So multi-threading is much more computationally efficient compared to this thing. Okay. And I just wanted to ensure that the recording has been turned on. Okay, fine. So it is much more efficient compared to the fork, use of fork, basically, right? So let us try to understand what it is about, right? So this is something actually I believe that you have already learned as part of your OS course. And have you learned, has threading been covered so far?
Yes, sir.
Can one of you confirm? Yeah. And also, if you recall, in the last lab also, Professor Gupta, he briefly touched upon threading, right? So he showed some code sample as well, right? So I think you are already quite you know what has to be done. However, let me just have a quick recap of the main things that are important to implement multi-threading in your assignment, right? So so threads, basically these are basically nothing but lightweight processes, right? However, unlike forking, which you did as part of your second assignment, multi-threading basically creates so forking, basically what it does, fork basically it creates an entire new process, right? And that is the reason actually it is computationally more heavier weight. Okay, it is heavier weight. Whereas the similar kind of thing doesn't happen in the case of threading, because so here actually you do not copy entire new process, right? You do not copy the entire data, right? So data and the functions as part of this mechanism, right? So so that is the reason actually it is lightweight, more lightweight, and it is more popular, like if you have to implement parallelism, basically threading is quite popular. So as I said, like if wherever you have to use parallelism in your code, you can use multi-threading. Yeah, so basically the performance of threading is improved with more number of physical processors. So this is very important, right? So basically if you are talking about like more number of processors, right? So or like if you have purchased your desktop PC or whatever, right? So these cores, right? So you have more cores, right? So quad core, or octa core, so like that, so you have the more the number of cores, basically the performance of your threading, basically the performance of the threads basically is going to be improved. So physical level basically performance also dictates to some extent the performance of these these multi-threaded programs. Okay, so the physical architecture, basically the physical architecture dictates the performance of the multi-threaded program. Achha. Now this is important. So you need to spawn threads, right? So the threads that are spawned from a process share the data structures such as code section, data section, and OS resources with the parent process. Okay, so only the execution logic is different. So threads basically so they are going to share, right? So the multiple threads that are created, they are going to share the data structures such as code section, data section, and OS resources from the parent process. Only the logic is going to be different. Now, what was the case with fork? In the case of fork, what happens? Is it the case? So in the case of fork, basically, do you have this kind of feature? You don't have, right? So that is the advantage actually of using threads, right? So context switching between threads is also much faster. So and that is why you get a better kind of feeling of parallelism, and the level of multi-threading also depends on the OS support, right? So an example of multi-threading would be like when you are browsing the internet using your web browser. So that becomes the main process, but the individual tabs that you open, these will be handled by the different threads, right? So that's an example of implementation of threads. Now let us talk about how you are going to implement multi-threading in your program. So for this, you need to use a couple of C functions. Okay. So these are actually part of the POSIX framework because you are implementing in Linux. So for implementing multi-threading, you need to take help of these functions. So first one is pthread create, right? And Professor Gupta also showed last time, if I recall, this was he had showed this thing also. So pthread create, okay, is basically for creating and defining new threads. So as this term create says, so if you have to create a thread, right? If you have to start a new thread, right? So this is the function that you will have to use in order to create and define a new thread. Now pthread join, okay, so pthread join, basically this function makes the master process wait for all the children processes children threads to finish, basically. Okay, so children threads, so until they finish, basically the master process will wait. Okay, and then the exit, pthread exit is for exit from a thread. So you need to use this particular header library, pthread.h, in order to use these functions. Okay, pthread.h. So let us have a high level view of each of these different functions. So the first one, create, pthread create. What are the arguments it takes? First one is the thread ID, which is the ID of the thread. Okay, the second one is the thread attribute, the attribute of the thread, which is null by default. The start routine is basically the function which the thread will execute upon being called. Okay, so when you create this particular thread, okay, a particular function will have to be executed, right? This is what you want to do. So that function will be the name of the function is going to be the third argument. And finally, arg basically is any argument that you may want to pass to the routine. So sometimes like this routine, okay, will be taking certain arguments. Okay, so these arguments you are specifying over here. This is how basically this pthread create function has been specified, right? So this is how the function has been written. Okay, so basically, this function start routine will be executed, and the arguments that you want to pass to that function, those you specify as part of it. Okay, so let us have a look at the at a sample program, right? So it's not a complete program, but I just wanted to give you a sketch. So how you can write using pthreads, how you can write a program using pthreads. So the first thing you notice is the inclusion of the header pthread.h, include pthread.h. Okay, so this is the function that we want to execute, and the argument that we want to pass is the TID. So first, what we are going to do in the main function. Okay, so pthread, this thing is okay. So you want to you look over here for int I equal to 0, I less than 5, I plus plus, pthread create thread ID. What was the next one? You remember? Thread attribute, right? So thread attribute, normally you will be writing null, right? So normally it will be null for all the programs that we write. However, if you are curious, what are the different other attributes that are possible? For that, there are so many different manuals that are there. Okay, so which will give you the list of different thread attributes that you can use. So if you search in the internet for pthreads library and the different attribute types that the thread attribute types that it supports, basically you will be able to get the list of all these different attributes. But for our purposes, mostly it is going to be null. Okay, so this is going to be null. Then, as I was telling you, the next attribute over here is fun, right? So this fun is basically this function that was defined over here, which we want to be executed on the creation of the thread. So this function is going to be executed. Okay, and I is what? I basically is the argument that we are passing to fun. So it is going to be the TID, basically the TID over here. So so this particular loop, what it is doing, it is creating thread 0, thread 1, thread 2, thread 3, thread 4, and thread 4. So thread 0, 1, 2, 3, and 4. So 5 threads are going to be created because of this particular loop. Now, what does pthread join do? Who can tell me? Right. So this basically, as I was telling you earlier, it will make the master process wait for all child threads to finish. Okay. So what we have done over here, pthread join, we have passed as one of the arguments thread ID num -1. So here it is going to be thread ID 4. So that means the last thread ID is going to be taken. So this is the way this program is implemented, that until the execution of this particular thread ID 4 is finished, basically we are making the main process, the master process, to wait. Okay, and so like that, you print. And the other function that I wanted to execute is the pthread exit function, which is also implemented in this particular program. So pthread exit, and what does pthread exit do? Once again, exit from the thread. So once this completion of the execution of this thing is done, you exit from the thread. Okay. Now, one of the problems, as you have, I'm sure that you have done quite a bit of, you already have quite a bit of understanding of critical section and mutex locks, etc. You know what is mutex, all of you? It has been covered in the class. Yes.
Yes.
Very good. So let us have a look at how you are going to use the mutex function. Okay. So just a recap, basically, so when you have multiple processes which share the same resource. Okay, as you know that synchronization problem will arise. Now, so basically the critical resources must not be modified by more than 2 threads or processes simultaneously. So, in order to do it, you take help of mutex locks. So, mutex locks basically they are going to ensure that the synchronization is maintained by the competing threads. You have the same set of resources, you have multiple threads, the synchronization has to be maintained, and for that these mutex locks can be used to do it. So, what are the different so these are some of these different things that you can use for implementing this mutex. So, the most important is the mutex lock pthread underscore mutex underscore lock and the corresponding unlock. Lock basically locks the mutex named lock, and this unlock basically unlocks the mutex named lock, right. So, lock and unlock, these two functions with lock as an argument basically is implemented this way. Okay. Now, this pthread underscore mutex underscore t name, basically this is the binary mutex that is provided by the pthread library. Okay, so you need to use this mutex. So very quickly, we will have a look. So there, let us say that you are writing some function and there is a critical section. So this pthread mutex lock, basically it is going to lock the mutex before entering the critical section. Okay. Now int I equal to 0, val plus plus. So val plus plus basically, so this is the increment in the in the value of val. So this is basically what is val? Val is the global variable, right? So it is the global variable that is shared by all the threads, right? So this is the global variable. So that is the problem basically, So you have this global variable val. So val plus plus. Now while I is less than or equal to 5, printf val sleep and I plus plus. Okay, then you so finally what you do is you unlock. So you come out of the critical section, right? So when you get in, basically you lock, and you come out, you unlock. So that's all that you will be mostly requiring, and whatever you know so far by virtue of the previous lab classes. So those things like the assignments that you did, etc., plus this concept